Welcome to the Unit 9 guided practice. Let's go ahead and jump into the academic vocabulary. You will need to memorize this for your retest. Starting with the dissociation. Dissociation is the process of separating a salt into its ion forms. It's basically just a fancy word for dissolving. Solubility. Solubility is the ability of a substance to dissociate or dissolve. And so solubility is the ability to dissolve. A solute is the substance that is being dissolved. Solvent is the substance that dissolves the solute. And the solution is the homogeneous mixture of a solute and solvent. Looking at concentration, concentration is the density of material in a solution. So it's how much solute you have in the solvent. The dissolution, dilution, not dissolution, but dilution is when a substance moves from a higher concentration to a lower concentration. Molarity, molarity is the concentration of a substance measured in moles per liter. Molality is also concentration, but it's measured in moles per kilogram. A colligative property is the properties of a solution that depend on the number of solute ions in solution. Boiling point elevation is the increase in boiling point of a substance due to the addition of a solute. And the freezing point depression is the decrease in the freezing point of a substance due to the addition of a solute. You need to make sure that we have those memorized for your retest. Looking at a solution, it says what is the solute and solvent in salt water. And so when we're looking at solute, solvent, the solute is going to be the salt, the solvent is going to be the water. B, it says what determines if a solute will dissolve in a solvent. So we use the phrase like will dissolve like. So polar will dissolve polar, and nonpolar will dissolve nonpolar. Meaning, if we have something polar, things are going to be our ionic compounds. They're going to dissolve in water because water is also polar. And so it has to have the same polarity for it to dissolve. And it says C, choose a suitable solvent for potassium bromide, then draw a molecular level diagram explaining / showing the dissolving potassium bromide. So potassium bromide is an ionic compound. So therefore, potassium is positive, bromine's negative. And what happens is in the water, the potassium, since it's positive, is going to get surrounded by the negative part of the water, which is the oxygen part. And what it does is just oxygen comes along and just surrounds that water and surrounds that potassium with water. And it looks like that. Concentration says what is the difference between molarity and molality and what are the advantages of each. Molarity is just concentration measured in moles per liter. It's really easy to measure molarity. We measure the mass of the substance that we put in it, and we know the volume because it's in a graduated cylinder or a volumetric flask. Molality is measured in moles per kilogram, and this is useful because if we're measuring the concentration of gases in other gases, the volume is going to change, and so therefore we want to use something that is not going to change the volume, and so we use kilograms instead of liters. Because we don't want the mass will never change, but the volume will for gases. B, it says what is the molarity of a solution when 10 kilograms of our lithium cyanide is dissolved in 480 milliliters of water. So we know that it wants molarity, so it's going to be moles. Molarity equals moles all over liters. We can convert our milliliters to liters by dividing by 1,000. So we know that we have 0.480 liters, and all we need is moles. So how do we go from grams of lithium to moles of lithium cyanide? We take 10 grams of LiCN, and all we have to do is set it up and divide by the molar mass, which our molar mass is going to be 32.95 equals 1 mole, and we'll get a molar amount of 0.303 moles. And we just divide this out with a calculator and we get a molarity of 0.632 molar. Now on the C, it says what mass of our calcium nitrate is required to make a 250 milliliters of a 0.4 molar solution. So what you're going to do is you're going to do the exact opposite of what we just did. We know that if we take this equation and solve for moles, well, moles equals our molarity times liters, and then all you have to do is take your moles and multiply by the molar mass of our calcium nitrate, which our molar mass for calcium nitrate is 164.1 grams in 1 mole. Now if you do this correctly, you should get a molar amount of 16.41 grams. So go ahead and try this out and see if you can't get that answer right there. Next, it says, how could you tell the difference between a concentrated solution and a dilute solution of Kool-Aid? We know that a dilute solution of Kool-Aid is going to be very light colored, and a concentrated solution is going to be very dark colored. It says B, what is the molarity of a solution when 200 milliliters of a 0.5 molar solution has 300 milliliters of water added to it? So we're going to use the equation M1 V1 equals M2 V2. And so with this, we're starting with 200 milliliters, that's our V1, and then our molarity 1 is 0.5 molar, equals M2, which we don't know, we're trying to find that, so that would be X, and our V2. After we add 300 milliliters to it, we'll have a final volume of 500 mils, because 200 plus 300 is 500. We divide this out and we get a concentration of 0.333 molar solution. Now you're going to do the same exact thing on C, but you're solving for volume here. You should get a final volume of 625 milliliters. See if you can use the same equation and work it out and get that one. A, it says define colligative properties and give 3 examples of them. So when we're looking at this, colligative properties, as we said, it's what happens when you put a solute in a solvent. An example of this would be boiling point elevation, freezing point depression, and the lowering of vapor pressure. Those would be 3 examples. It says draw a diagram of how potassium chloride can affect the attraction between water molecules. And so when we take our sodium chloride, it's polar, and sodium is going to be positive. So therefore all the water molecules are going to line up with all the oxygens near it. And what it's going to do is it's going to organize all these water molecules. And by doing this, it organizes them and creates intermolecular attraction between the water molecules. And so what this does is it enables the boiling point to be elevated and the freezing point to be lowered. And moving on to our next one, it says when adding sodium chloride to water, what happens to the boiling point? When you add salt to water, since you've added it in and all these water molecules are now organized, we know that the boiling point, you have to put in more heat, more energy in to break up these intermolecular attractions, and so the boiling point gets elevated. Solubility of gases and solids. It says what can you increase, or how can you increase the solubility of a gas? You lower the temperature. How can you increase the solubility of a solid? You increase the temperature. And which of the following has the greatest solubility at 20 degrees Celsius? So what we do is we take it, there's 20 degrees right there, go up, and we see that potassium iodide has the greatest solubility.